All right, folks, day 9, first video. We're going to cover questions 13, 14, 15, as you can see on the page in front of you. 13 is kind of an odd one, all right? So we have the square root of x plus the square root of x, and that's got to equal something between 4.4 and 4.5. So we could just say 4.4. Well, if you're not sure about that, let's go back to 4.4 can be written as 4.40. 4.5 can be written as 4.50. And when you write it then like that, then it's easy to say, oh, between 4.40 and 4.50 would be 4.45, in the same way that 45 is between 40 and 50. So we're going to say 4.45. Now, how would we solve this equation? Well, if I have x plus x, it would be 2x. Well, if I have the square root of x plus the square root of x, it's the same thing. We could write it like this: 2 some square root of x. And the way they would pronounce that is 2 root x. And that equals 4.45. Now we just have to go through the process of figuring out how to get x by itself. So how can we get x by itself? Well, first thing I'm going to do is divide both sides by 2. So we're going to need to do 4.45 divided by 2, and we get 2.225. Thank you to Lily, who did that really quick for me. All right, and obviously this cancels, and I'm left with the square root of x. Now I don't want the square root of x, I want x squared. So now I've got to take that 2.225 and I've got to square it, because the way I cancel out square root is by squaring. So I'm going to square both sides, and when I do that, and when you're trying to square something, it's like the little x that has a little 2 up in the right hand corner, and you're going to get something in the neighborhood of 4.95. Okay, so I would probably just round that, and if you look carefully, it says where x has to be an integer. Okay, so what is an integer? Remember, an integer is a whole number. So 4.95 would not be acceptable, but the closest integer to 4.95 would be 5. And now I'm realizing I just did the whole problem for you, but that's okay. Question 14. Question 14. All right, now what we have to do is we are trying to figure out which one of these represents a function. So the only thing that I have to remind you that a graph of a function is going to be a straight line, okay, but not vertical. Remember, if it is a vertical line, then one input has many outputs. Question 15 is pretty straightforward. We've got a triangle that looks like it has been moved down the line. Oh, that is a really bad triangle. Let me try again. Pretend you didn't see this line right here. Okay, so the first is most obvious thing is if it's gotten bigger, then we know it's a dilation. And then all we have to decide is, did this reflect or did it just translate? All right, hopefully that'll help you on question 13, 14, and 15. And special thanks to Lily, who scrambled and got me a calculator while I was doing this problem.